Now that you're embarking on the beta curriculum, I want to just begin by saying that I'm assuming that you have finished the alpha curriculum successfully and your child knows his adding and subtracting facts, and he has them down cold, and he's not vacuum cleaning or any little tricks, he just really knows them. If not, then I would suggest that you go back, because we're assuming that in this book. What you'll need is you'll need blocks. If you've already purchased blocks before, you should be all set. If you feel like you need more blocks to make 10 of everything instead of 4, then you might want to consider getting the completer set. We also have a skip count tape with addition fact songs that you probably used in the previous book, but with the skip count tape, we're going to be skip counting in this book, and that would be an assist. Now, next, please watch the introduction that's following and read the introduction in the textbook, and I would like to suggest that maybe you do it maybe a couple weeks later, because Matthew C is a completely different approach to teaching math, and it'll be a good review for you. So I hope that you will enjoy your math experience and have fun. So first of all, let me tell you thank you for watching this part of the video. Many people skip it, and it's essential that you do watch it. Now, Matthew C is not just blocks, and it's not just videos, and it's not just books. It's the way we use these components that makes Matthew C what's different. And so the goal of Matthew C, number one, is that we teach children to be effective problem solvers. I often begin by saying this. Okay, here's my audience. I'll ask you. Why do we learn math? To do word problems, or to apply. That has negative connotations for many people. So the reason we learn math is to apply math in real life situations. So one time I was teaching junior high students, and I had 7 students. And I brought in 14 objects, and I said to them, okay, how many do you each get? 7 students, 14 objects. What did you think they said? That's right. They said, what do we do? Add, subtract, multiply, divide. Because, you see, they knew how to multiply and how to add and how to do all these operations. But when to do which one is critical. Okay? So we want to teach not only the process or the rule, we want to teach the concept underlying. It's important that you know how to multiply. It's equally important that you know when to multiply. So it's more than just memorization of facts. To be a real solid math student, you have to know how to do the operations and why you do which operation when. Okay, so to get the most out of Matthew C, there are 4 steps we're going to go through. The first one is prepare for the lesson. And then the second one is present the new topic to the student. The third one is practice to acquire mastery. And the fourth one is proceed to the next lesson after the student demonstrates mastery. Confucius was reported to have said, now I wasn't there, but here's what he was supposed to have said. Tell me, I forget. Show me, I understand. Let me do it, I will remember. And we're adding step 4, which is, let me teach it back to you to demonstrate that I've mastered it. So it makes sense when you think about it, because what we're going to do is we're going to encourage you to, number 1, watch the video. Why would you do that? So that you understand what the concept is. Now these videos, I taught a methods of teaching math class at the college level one summer, and it's essentially the first 4 videos, the whole content of that class. So you're really being trained as the teacher to understand what the concept is. Number 2, once you understand it, you want to present it to your student. How are you going to do that? Well, most kids learn better when they can see it, touch it, and feel it. So you're going to use the blocks to teach your student. But it's one thing to watch someone else do it, another thing to do it yourself. And so step 3 is you're going to get out the textbooks and provide review and practice. And then normally what do you do after you've taught something and the students finished all the worksheets? Take a test, right? Now, in our society today, we normally do 2 things, workbooks and then a test. What we're adding is the first 2 steps, which is watch the video till you understand it, and then number 2, use manipulatives so that the child understands it. Then we go to the textbook, and then we go to the test. All right. So, step number 1, prepare for the lesson. You want to watch the video, and you want to read the teacher manual, which has examples, illustrations, and some people learn better by watching, some learn better by reading. We're giving you both options. But it is a visual program, and it's pretty tough, I think, just to read an explanation. It's much more effective to watch me teaching it. Now, I'll be using a board. I'll be the same guy, sometimes older, sometimes younger, but we'll be using the same manipulatives, And you have to make a determination. Try it yourself a few times, watch the video as the teacher. But some kids really like to watch it themselves, or they want to watch it with you. Either way, you be the judge of what you do for your own students. Step number 2, present the new topic to the student, or what I like to say is show and tell. Because usually when I'm teaching a student or a class, I let the blocks, whether it's the overlays or the blocks, and a piece of paper and a pencil, and I present the new material. Now I keep teaching until he goes like that, or when the lights go on. If they don't get it, then I'm going to go back and do it again. Now I have to tell you that some of my kids that I've taught, they got it the first time I taught it, and then we went to the worksheets. Some kids, though, I've spent 3 weeks teaching a concept until I really felt that they understood it. And I'm going to give you one tip. If you have a child with any kind of learning problem, here's what I've done. Sometimes I don't even ask them for any feedback the first couple days. I simply model the approach, and I'll do 4 or 5 problems each day. And I say, you just watch, and as I'm doing the problem, I'll write it, I'll say it, I'll build it, and I'll just model exactly how you should solve the problem. By day 3, usually that particular student was ready to go. But we spent years working out that between us until we finally acquired that effective way of teaching. So sometimes, don't be afraid. Continue to do it. Now, we say over and over in the video and in the books, build it, write it, say it. What does that mean? You want to have the visual with the blocks, you want to have the auditory with the saying, and you want to have the writing part too. So build it, write it, say it. Sometimes I build it, and then they write it. Sometimes I say it, and they build it. Sometimes I write it, and they build it and say it. So use all 3. Okay, now, next step is practice to acquire mastery. In other words, let them do it. Because when a student's watching me do math, they go, oh, that's easy. You know how you've watched professional athletes? Oh, that's easy. But when you try to do it yourself, it's a different thing, isn't it? So make sure that they have plenty of practice. Now, in your student textbooks, you have 3 lesson practice sheets. You may or may not use all of those sheets. If they get it using the problems on the first sheet, then you proceed to the lesson review pages. But if they don't get it, spend some time there. You've got 3 pages, all right? You also have word problems in these pages. Now, these word problems are just focusing on that particular topic. So pull some word problems up, because why do we teach math? To do word problems, right? Our goal is to the student understands math and knows how to do it so they can apply it to real life situations. Now, there's enough examples there that most people won't use all 3 pages, but you as the teacher determine how much you're going to use or how much you're not going to use. So for the slower learner, you've got plenty of problems. For your accelerated learner, or a lesson that they really get quickly, just move on, all right? But you be the judge of that. Okay, step 4. Now, this is often tough for people to get, but let the students demonstrate to you that they have really mastered the program. So we do have tests at the end of each lesson. We have systematic review worksheets. So each lesson has, how many is this? 6 pages. You've got the first 3 are on the topic in that lesson. The next 3 are reviewing that topic plus everything you've had up to that point. They're cumulative review. I suggest that you do all 3 of those, all right? Oftentimes, in those pages, you also have a little lesson that's called a quick review down at the bottom of the student sheets. And these quick reviews bring up something that you've had in the past. So let's say you're in the multiplication book. You haven't had regrouping for months. So there'll be a little lesson in there, a little quick review, a little teaching, regrouping. So you as the teacher say, remember that? If they say yes, good. If they don't have it, it's a good time to bring it back and bring it back up to speed. Now, the word problems in these student review, these systematic review worksheets, they're from all over the place. They're from all the stuff you've had in the past. They're good. But you might find a student say, boy, I forgot how to do that. Well, that's a teachable moment. Take that time, focus on it, bring it back up to speed. They're carefully designed for that purpose. Now, the last thing is, doesn't every child want to be the teacher? Let them play teacher. You pretend you're the student. This is how you really determine whether they know their stuff. And so you say, okay, teach me the lesson. And they have to teach you what the concept is, how to use the blocks, how to build it, how to write it, how to say it, where to apply it, and let them be the teacher. And that's the only way you're really going to know if your student has mastered that material. Now, you might say, that's kind of a high goal. But, you know, it's more than just producing confident math students. Math is sequential. It hurts me. I used to be a high school math teacher, and if I had students that had come all the way to 10th grade and couldn't multiply or couldn't do fractions, then how am I going to teach them how to multiply exponents or add fractional exponents? So math is sequential. Don't go to subtracting till you've finished adding. Don't go to multiplying till you've finished adding and subtracting. Don't go to dividing until you've done all three, because dividing, you will use all those operations in one problem. See? So math is sequential. So somebody will ask me then, and I get many phone calls, when should we finish this book? How long should we take on a lesson? And having heard all this, what would be the answer? As long as you need, right? Because you as the teacher, now we've given you tests, we've given you these 4 steps, and use all the data that you have at your disposal. You can tell whether somebody really gets it. If the lights are going on, they're able to reproduce it, they're able to teach it back to you, then I'd feel comfortable in moving to the next lesson. But if not, take your time. You've got time is on your side. And make sure that you get math now at an early age so that they won't have to spend the next 50 years wondering how to do problems. Now, here we go. The first lesson is place value. And you know, I almost teach this in every one of my books. And I don't want to be, if you've already seen this before, you could probably fast forward and you can probably review this. But place value is so important in the decimal system that we're going to review it again for you. Hopefully you have understood it already. Okay, place value. Ready, students? I wish you could see all their nice blocks, because, you know, when kids play with blocks, you're supposed to encourage this, by the way. And I've been in schools where they call this free exploration. And that means children playing with blocks, okay? But that sounds more educational, doesn't it? Free exploration. So, because if you're building that fort over there, now I noticed that your fort right there, the bottom wall is 12. And if you run out of 12s, you had to pick up 2 6s, didn't you? Oh, if you're not careful, you'll learn some adding there, right? The 2 6s makes 12. And now I see 2 5s and a 2 in the next row. 2 5s makes 10 plus 2 makes 12 again, right? Pretty cool. So I encourage students to build things and to play with the blocks. In fact, I have one of my reps even makes candy dishes out of the blocks. She gets hot glue and she puts them all together. I should bring that and show you sometime. Okay, so it's okay to play with the blocks, but not now. You have to pay attention. You ready? Okay, here's my definition of place value. Every value has its own place. Tell me that. Every value has its own place. Okay, what is a value? Because, see, in math we have this. You have 0, 1, 2, 3, to 9. Those are the digits that tell us how many. All right? But 9 what? 3 what? 2 what? And that's where the values come in. So let me see your blocks here. This is what? This is 1 green unit. Now many people call these the ones, but I call them units because 1 is a number that tells me how many, okay? But unit tells me what kind. I think it's a good distinction. Now what am I doing with these big ones up here? Because you can't see these very well on the television, right? So we made them bigger. And these have cool little magnets on the back, but they're not hollow like yours. So I lose a little bit, but so this is the unit, all right? Find me a 10 bar. If that's 1 unit, find me a 10. Very good. And this is also a 10, all right? And then if that's 10, find me 100. 100. Okay. So this is the units, the tens, and the hundreds. These tell us what value or what kind. So sometimes I ask tricky questions. You want a tricky question? Well, like what's larger, 2 or 1? This is tricky. I warned you, tricky question, right? What's larger, 2 or 1? You don't know. because you don't know, you're supposed to say 2 or 1 what? See? Because if I had 2 units and only 1/10, then the 1/10 is larger, right? But if I have 2 units, but what if I had 2 tens and 1 unit? Now which is larger? The 2 tens. So if I say to you, what's larger, 1 or 2, you should say, excuse me, Mr. Demi, 1 or 2 what? You didn't give me enough information. See, and it's that way with even dollar bills. Sometimes I open up my wallet and I say, what would you like if you could have them? Would you like one of these bills or one of the ones that I have 2 of? And what should your first question be? Excuse me, Mr. Demi, that's right. Are they 10s, 20s, or $100 bills, right? Because I want the big ones, because then you get more, right? Unless you're kind and let me keep them. All right. So here we go. Place value. 0 through 9 tells you how many, and units, tens, hundreds, thousands, millions, billions tell you what kind or what value. Now the way we teach this, and sometimes older students, sometimes they're larger too, but sometimes older students don't always get my humor, but if you just smile, that will help me. Decimal Street. And Decimal Street, because I started thinking, if I was a child, a young student, if I heard someone say every value has its own place, I'd think that must be where they live, right? Now you live way up right that way, and you live just right over the hill there. So where do the units live? This is a cul-de-sac, great place for riding bikes, and they live in a little green house at the end of the street. Okay? Now, don't forget, you count 0 to 9, and that's a little tip, because it turns out in the decimal system where everything's based on base 10, that you can only have how many guys in this house? 9. And then it's kind of a rule of the town that you have to buy another house if you want to, you want to still live there. Because if you get more than 9, you have to move. So how many do I have there today?
4.
4. Okay, there's 4 guys home today. Now, who lives next door to the units? Don't get too far ahead of me now. This is the tall blue guys, right? They walk around, they play basketball, and they all wear blue. Well, let's put a couple up there first, okay? So how many blue guys can live in this house at one time? It must be a little bit deeper to fit. Yes? 9. Very good. You can only have 9 in this house. And who lives next door to the tall 10s?
The hundreds.
The hundreds. Ooh, look at this. Make a castle for them. Okay, this is the hundreds castle. We'll put one there. And it's a deep house, so you can get 9 of these guys in there, right? So, how many beds would be in the unit's house?
9.
What color would they be?
Green.
Green. Okay. How many beds would be in the...
9.
What color would they be?
Blue.
Would they be short or like long?
Long.
Very long. See, that's where I live. See, tall and blue. Why are you laughing? This is my house. Okay. And who lives here?
The hundreds.
The giants, right? The big red guys. All right. Everybody get this? Okay. Now, if I was teaching you at home, though, I wouldn't be using magnetic blocks and standing up here all dressed up. I'd probably be sitting in front of a table opposite you, and I would build a couple, and then we'd write in the numbers, and then we're going to say it. See, we built it, we wrote it, now we're going to say it. Ready? 100, 3 tens, 4 units. Or 100, 3T4. 3T4? I'll get to that in a minute. 134. All right? So we're going to build it, write it, say it. But now, if I was teaching you, I'd probably do 3 or 4 examples. We do them together. And then I might say, you show me one. So you get ready with your blocks. Show me 142. 142. Okay, should look something like that, shouldn't it?
Yeah.
Now the hundreds go to the left, and the tens go, and then the units, and we build it, and then we write it. 100, 4 tens, 2 units. That make sense? Okay, and then I might just write some numbers in here and let you build it and say it. So we're going to use all 3 different ways, and there's some examples of that in the teacher's manual, okay? Now, show me this one. This is a little bit trickier. Oh, you just did. Show me 42. 42. Okay, put them down in the blocks there. I read an article once where they were talking about the fact that they had students, some from the East, the Far East, over in Asia, and versus Western students. That would be people around North America. And they said to them, show us 42, and they gave them blocks. And all of the Eastern students did just what you just did. They got 4 tens, 2 units. But you know what all the Western students, the American kids, did? They got 42 of these and put them in a long line because they didn't understand place value. And so they began to study that, and they found out that one of the reasons they didn't understand place value was because of our language. Because, and let me show you this now. I want you to say this number now.
63.
Now, T represents 10. It's a suffix, right? So 6T3, and we say it as we move from left to right. How about this one?
71.
Now, not 7D, 7T. Let me see your teeth. 7T1. And that means 7 tens, 1 unit. Okay? But how about this one now?
16.
What in the world? We started over here. You said 6, sounded like 60. See, it's confusing.
26.
Okay, so because if you say 16, you actually go backwards, see? And so our teens are a little bit goofy, and the teens, turns out, mess up our understanding of place value. So what we did was, and some people aren't going to like this too much because it's a little bit different, but if it will help us understand place value, which is the foundation for everything in the decimal system, then I think it's worth a try. What we say is, and watch this, everybody.
91. 84. 76. 65. 43.
Now we spell that one a little different than we think because we take out the U, but still we say 4T3, no problem. Now we got 3 more, they're a little bit different. What should that one be? How many tens?
5.
And what's the word for 10? So shouldn't we say 5T9?
Yeah.
And we kind of do, except if you say 5T a lot of times, 5T divided by 50, you get 50, right? So, but it's still 5T50, pretty close. How about this one? What should this one be? How many tens?
3T.
Should be 3T7, but 3T30, they're close, so we'll let it go. This is a little bit of a stretch here. What should this one be?
2T.
Should be 2T.
2T.
I think it sounds cuter anyway, but 2T8, except 2T doesn't what we use. What do we use? 20. But we're still saying the tens first, then the units. So these are all consistent. Tens first, then units. And then we get goofed up when we say 16. Okay, what should we say?
1T6.
1T6. But you have to enunciate because 1T kind of does sound like 20, especially if you just 1T, you know, just kind of roll them off. All right, now, so here's what, but people say, yes, but I've heard 16 9 million times and it's already in my memory banks. So here's what I'm going to suggest. 16 is the nickname. That's Allie. That's not her real name. On her birth certificate it says Allison, right? But Allie, nickname. But the proper name is 1T6, okay? And if that will help us to learn place value, all I want you to do is when you see this, be thinking that's 110, 6 units. And if saying it helps you to think it, then we're going to do it. But we're still going to use 16 because everybody else in the world uses 16, right? You want to be 16? Yeah, you get your license, right? Okay. Okay, so count with me now. Ready?
8, 9, 10.
10's the nickname, but what's the real name? This is the hardest one right here. 1T.
1T.
1T1.
1T2. 1T3.
Good job. Okay, so we're going to learn both, all right? So someday, instead of going to the 7-Eleven, you'll say, Mom, I need to go to the 7-1T1. Okay. So that explains place value. Now, what I used when I taught my son place value, my fourth son, and there's a template for this, something similar, and you can tell this is not very professional because I built it. But I got a big piece of cardboard, and I put a little units house that just holds enough for 9 of those little green guys. And then I built a tens house that just holds 10. And then I built a hundreds house, just 9 tens and then 9 hundreds. Does that make sense? Then I put a little piece of laminated stuff down here so that I could write in the numbers, put in the blocks, then we can erase it and do it again. I like to use little dry erasers. But you can do whatever you want. This is just one idea. But it really helps to get this. Who lives next door to the hundreds?
1,000.
Oh, we're going to get to that later, okay? But there are bigger numbers, but these 3 are the big ones because whether you're doing thousands, millions, billions, you always have a units, tens, hundreds place inside that, okay? All right. So take your time with place value, understand it. If you already have it, you can review it and move to the next lesson. Okay, here I have 3 blocks up here, and hopefully you know all the identities of your blocks. If not, take some time and learn them. This is one of our most fun ones because what's this guy's name? It's Chocolate because it reminds us of chocolate, but it's really the 8 bar, right? What's this one right here?
Pinky. Oh.
3. We don't have to get too creative. This is a 3. What's this one here? 6. Very good. Okay. Now, the reason that we use these is because when we add, we don't want to be counting when we add. So we took a bunch of these green ones and glued them together, painted them a different color. So this is the same as 3 green units, except it's now a 3 bar, right? And this is the same as 6 green units. Now, I want you to put them in a sequence. A sequence is an orderly progression, and I'm going to describe the sequence. Now, the first sequence, I want you to tell me if you can put these numbers in order from the smallest, that would be on the left, to the largest. Okay? So which one do you think would go to the left? Yes?
Pink.
The 3. Okay? And then which one goes next?
The 1.
The purple or the lilac, depending whether, you know. I'll let people pick their own colors. So this is number 3, number 6, and number 8. And so what you'd say is 3, 6, and 8 are 3 numbers put in sequence. Now this is much easier when you have blocks, isn't it? Because sometimes when people see just numbers and say put them in order, they say, oh, how do I do that? So it's pretty easy when you have the blocks. So you want to use the blocks and write the numbers, okay? 3, 6, and 8. Okay, now, try this one. Put these 3 numbers in order from smallest to largest, once again. 10, 50, and 20. 10, 50, and 20. And when you get good at this, you can even try before you use the blocks. There's 10. There's 20. And there's 50. Now we want the smallest to the left and the largest to the right. So what do we have to change? This big guy here's got to move over here. All right. So we'll move these over here, put these right here. All right. So what's the order now? 10, 20, 50. Good, you put them in the proper sequence that I suggested. But sometimes I might say, put these numbers in order from largest to smallest. Ready? Here they are, 3 numbers. 14 or 1T4, 23, 9. So you want to build those 3 first. And this is good practice with place value, right? Because you have to understand place value. So there's 1T4. I need a 4. And there's 2t3. So I need a 2t. There you go. And now I need a 9. Okay. Now this time I want from largest to smallest. Largest to the left, smallest to the right. Okay. What do you got there, Caleb? Which one goes first?
The pink.
This one goes over here? All right. So we'll put 23 over here. And we have, okay, large, that's good. So now we have 23, 14, and we have 9. Now how could you have done that though without the blocks? Because the blocks just help us to learn the concepts. What if you just looked at those three numbers right away? Some people might think that this guy was the largest, right? So you get a 9. Or maybe the 4, because 4 is larger than a 2 or a 3. So you have to understand place value, and you might even want to put in a 0 there, because the real way that you would, here's how you do it. Watch. Magic hands. You first have to look at what's in the 10 place for all of them. So in the 10 place here, 10 place here, 10 place here, because the numbers get larger as they move to the left, right? Units, tens, hundreds. They're huge. So what you have to do is you say, okay, what's larger? 0, 2, or 1? 2. So these two tens are largest. And then the 1 10 is the next, and 0 10 is the next. But you start with the tens, and then you moved to the right, okay? Because now I'm going to give you a tough one. Write these three numbers down. 49. 103. And 61. Okay. Now the question on the floor is, if we were to put these in order from largest to smallest, do they all have the same number of places? Who's got the, what do you think is the largest number so far? Okay, here's what I would suggest though. Because this has 3 and these both have 2, I'd put some zeros in here so that they all have 3 place values covered. Okay, now let's start looking. We've got 0, 1, and 0. So which one do you think is going to be the largest so far? Which one? The 0, the 1, or the 0? The 1. Okay. Now this is built in your book, so I'm not going to build this one. I'm just going to show them. Okay, so this one's over here. 103. Can't see that one. 103. So this one's gone now. Now, which is larger, 04 or 06? 06. So that's the next largest. 061, and then 049. And then when I was all done, I'd go back and I'd take out these zeros, right? So is this largest to smallest? Yeah. Very good. Okay. And then sometimes we want to get you to start looking for patterns. See if you can figure out this pattern here. Are they going up or down, the numbers? Right away, what do you think?
Down.
Down. Because this is the big boy, right? These are little guys, so it's going down. How much is it going down? How much between here and here?
1 each time.
1 each time. So what do you think would go here?
5.
What do you think would go here?
8.
Ooh, pretty good. And if you wanted to, again, you could use your blocks. You could put a 9. You could put a 6. You can put a 7. And you think, huh, because what you guys just told me was we should put an 8 here and a 5 here. And that looks pretty good to me, too. So that's 8 and that's 5. All right? So this is also looking for patterns in the math. And this is learning how to compare numbers. Okay. How do you describe a number? If you say a number is larger than something or smaller than something, what's the symbol for larger or smaller? Do you know? What's the symbol when two things are exactly the same? equal, right? So if you have something like 3 equals 3, then you're all set. But what if you have like 12 and 8? What do I put in between them because they're not equal?
You draw an arrow
Draw an arrow, okay?
pointing to the 8.
Now, and these arrows, though, they have a big end, and then they got a little pointed end, right? So where does the pointed end point to?
The 8.
The pointed one goes to the 8, okay? Because, now there's all kinds of ways you can think about this. Sometimes you think about, this is an alligator mouth, and the alligator wants the biggest number to eat, and so he's always pointed to the biggest number. Or you could think that this is the widest opening, so that goes to the biggest number. This is the small opening, goes to the small number. Okay, whichever you want, that's fine. Now here's how you say it though. Once you put in the symbol, you read it from left to right, and you say 12 is greater than 8. Now what if you had this? How are you going to read that? You don't want to read 12 is greater than 8, right? Because we have to read from left to right. So what do you say?
8 is smaller than 12.
8 is smaller than 12. 8 is less than 12, okay? Because you read along from left to right. So you try this one. Where should I put the arrow? The big end at the 9?
Yes.
Okay, and then how do we read it? 7 is less than 9. Good. But what if you have something like this where you have and we're going to put a circle there because that circle is saying, write in me. Put a symbol in me. And we have 3 symbols to choose from. We can either put in an equal sign or a greater than sign or a less than sign. So which symbol goes in there?
The less than.
Oh,
The very bottom one.
Well, you know what the first thing we have to do is we have to solve it. So what's 9 plus 4?
13.
13. And what's 5 plus 7?
12.
Okay, now which one is the largest?
13.
Okay, so we put our symbol like this, and then we read it, 12 is less than 13. Very good. Okay? Let's do one more. And this is a good place for us to review our facts practice. 10 minus 3 and 9 minus 4. Okay, what did we do first? Had to subtract, right? What's 10 minus 3? 7. What's 9 minus 4? 5. Which is largest?
7.
7. Okay. 7
is
greater than 5. Very good. Okay, now we're going to do some rounding. We're going to round numbers. What does it mean to round a number? And why do we round numbers? Well, the reason that you round numbers is because when you start doing big adding problems and big subtracting problems and big multiplying and dividing problems, you want to be able to look at it and quickly get an estimate. But you don't want to use the whole number because that's a long process. You want to do a quick estimate. So you have to round them. So here's a number, 38. And I want to round that to the nearest tens place. Okay, hold on now. Nearest tens place. Okay, let's try you 3 right here in the middle on this one. Ready? Which is the next closest tens place to 38? Okay. What's this? What would that be if that was a 0? That'd just be 30, right? But what's 10 bigger than 30? 40. Very good. Okay? Because if we had built 38, if we had 38, and I said, what's the nearest tens place? You could say, well, 30, right? And then you could say, well, maybe we could replace this with this one and make 40, okay? So 38 is between 30 and 40, but which one is it closest to? That's the question. Now let me talk about the language a little bit. When I say I want to round this to the nearest 10, what I mean is when I'm all done, I don't want anything in the units place. What I want in there is I want a 0. And so that's why we call it rounding, maybe. because it's a round zero. But is 38 closer to 40 or is it closer to 30? Let's think about this a little bit more. Let's write the numbers out. 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. So there's our 40 and there's our 30. And I think you can see pretty quickly that 38 is closer to 40, right? And that's what the answer is, by the way. It is 40. But what about these other numbers? What if the number had been 32? What?
30.
It turns out that if it ends in a 1 or a 2 or a 3 or a 4, 4, 3, 2, or 1, if it ends in those, it rounds down to the 30, okay? But if it's a 6 or a 7 or an 8 or a 9, it rounds up to 40, all right? So what's the hard one, though? Which one is right in the middle?
35.
35. Now, what does 35 do? Does he just like go on strike or what? Does he go up or go down? He's got to go up or down. Somebody made a decision at some point in the world's history that it goes up. So 35 goes up, okay? So if a number ends in 5, 6, 7, 8, or 9, it goes up. If it ends in 4, 3, 2, 1, it goes down. Okay, so let's try one here. Let's try the number 13. Okay, 13. Now what's that between? I want to round it to the nearest 10. What two tens is that between?
10 and 20.
So cover it up, and that gives you the 10. And then just go up 1, and that gives you 20. Now, does it end in a... Here's what I did in the book for you. See if this helps you. 0, 1, 2, a 3, or a 4, it becomes a 0, right? It goes down. But if it ends in a 5, 6, 7, 8, or 9, it's one more. So that's a big 1, okay? So what does this end in? A 3? Right? That's over here. So what do you think? Is this going to be closer to 10 or to 20? 10. Very good. Okay? Let's try another one. These examples are found in your book. Let's try 75. Okay, the first one is, what two numbers is that between?
80 and 90.
Well, cover it up first.
70 and 80.
70 and 80. Now, does it end in a 5? So does that go down or go up? Up. Very good. Okay, you guys are whizzes. Now, here's where we use it. If we're adding two numbers, like 13 and 75, 75 rounds up to 80, right? And 13 rounds down to 10. And so we add these two up. 8 tens plus 1 10 is 9 tens. So it turns out our answer has to be real close to 90. And that's called estimating. Estimating is when you round both numbers and then add them up. Yes? The real answer is 88. 3 plus 5 is 8, and 1 plus 7 is 8. Is that pretty close to 90?
Yep.
Good. But if you'd have got 188 or 880, you'd say, oh, that can't be right, because it's not close to what you estimated. All right? Now, one other thing in this lesson is what we call commutative squares. And I don't know if you've ever done these before, but I think they're kind of fun. And here's what we're going to do. You think it's tic-tac-toe? No. This is adding. So if you have a 7 and a 1 and a 2 and a 3, first thing you want to do is you want to add this way. What's 7 plus 2?
9.
What's 1 plus 3?
4.
Okay. Now let's add across this way. What's 7 plus 1?
8.
What's 2 plus 3?
5.
5. Okay, now let's add down. 8 plus 5 is? 13. What's 9 plus 4? 13. They should come out to the same thing. If they don't, you may have messed up. You go back and check. But see what that's neat? You just had to add 1, 2, 3, 4, 5, 6 times, and it says a check. So when you get those, have fun doing them, and practice your adding facts. All right, what do we have up on the board here? Let's look at this first number. What's this? 100. How many tens? 2 tens and 5, no, 4 units. Okay, how would you write that? 124. Now, before we go any further, because I do want to add these two numbers, let me just back up a little bit. We have something in this lesson called place value notation. Place value notation is when you write like this. Take the 124 and write it as 100 plus 20 plus 4. So you end up separating, so you have your units, you have your tens, and you have the 100, right? So we call this place value notation because you separate the number and write it as in the different place values. Now, what concept are we going to use to learn how to add huge numbers? I mean, what do? What number is this right here? 100. How many tens? 5. So 135. So if I wanted to add those two, I put the plus sign, I put the lines like that. So what I could do now is let's add maybe like the 3 and the 1 and the 1 and the 2 and the 5.
No.
Why do you mean? Why can't you do that?
It's not place value.
Because here's the saying. If you're going to combine something, you have to add the same kind. The longer saying is to compare or combine, you must be the same kind. But comparing is like something we'll get into later. So right now, if you're going to add two things, they have to be the same kind or the same place value. So you can only add units to units, tens to tens, hundreds to hundreds. This is a huge concept. And the blocks show that you're going to add 5 and the 4 makes what?
9.
So I could put the 5 and the 4, smush them together, make a 9. Okay, then the 2 tens plus the 3 tens makes 5 tens, or 50. And the 100 plus the other 100 makes 200. So 4 plus 5 made 9. 2 tens plus 3 tens made 5 tens. 100 plus 100 made 200, right? Okay, so some tips. If you're adding problems like this, you might want to consider either drawing some lines or turning your line paper sideways, right? So that you make sure that you add units to units, tens to tens, hundreds to hundreds, or you could even add them using place value notation. You could say 124 plus 135. 4 plus 5 is 9. 3 tens plus 2 tens is 5 tens. 100 plus 100 is 200, right? It's the same thing. Some people like to use graph paper. Then each little square gets a number and you line them up straight above each other. All right? So remember, what's the saying again? To combine, you must be the same kind. And that applies to adding or subtracting. Now, I forgot to tell you one thing, though. What do you call two elements or the two parts of an adding problem? This is called an addend, and this is called an addend, and the answer is called the sum. Okay? So addend, and the answer is called the sum. That's some answer, isn't it? Okay, who thinks they're the fastest counter in the room here? You are? Okay. I want you to count these blocks for me. We're going to race. I'm going to count them as well. And you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I'm going to do a different technique and we'll see who wins. Ready? And you guys have to listen and you're the judges and you tell us who wins the race. Say it loudly so they can hear you. Okay, ready? Your mark, get set, go. 2, 4, 6, 8, 10. Can I try it again?
Mr. Dummy won.
Okay, let's try one more time. Of course I won. I'm the teacher. Okay, one more time. 2, 4, 6, 8, 10. Okay. Because what I was doing was I was skipping some of the numbers. I was only counting the end number. I skipped the first number. Instead of saying 1, 2, 3, 4, I was just going 2, 4, 6, 8, 10. And that's one way you can learn it. Here, you try it this time. This time, I'll say the first number quietly. You say the last number loudly. You can do this at home. Ready? 1.
2.
No. Let's try it again. You say the second number loudly. Ready? 1,
2.
3,
4.
5,
6.
7,
7.
9.
10.
Okay, good job. I think I heard 11 in the middle there, but the idea was it was loud. Okay, now, you want to practice this until you can go not only from 2, 4, 6, 8, 10, but all the way to 20. Okay? All right. Now, skip counting is important for about 5 reasons. I'm going to tell you a couple of them right here. The rest of them are in the book. But the main thing about skip counting is it gets us from adding to multiplying, right? So skip counting lays a foundation for multiplication. And it helps us to understand multiplication. And it's just a practical skill. Let me count your eyeballs. Ready? 2, 4, 6, 8, 10, 12, 14, 16, 18. See? So count by 2s. What else do you have 2 of? 2 ears. 2, 4, 6, 8, 10, 12. No, fingers, we'll count to that later. But so you use it as a practical skill. Skip counting also helps you when you get to fractions. Finding equivalent fractions, common multiples. And skip counting helps you to do patterns again in math. What if you looked on a sheet and you found this? Whoop, that should be an 8. So what numbers go in these two? 2 and 6, because this is the 2, 4, 6, 8, 10, the skip counting facts, right? Okay, so skip counting is important to learn. Now, we even have tapes to help you learn skip counting. And it's real nice singing. And the 2s, I'm not going to sing for you very much, just a little bit. 2, 4, 6, 8, 10, 12, 14, 16, 17. And singing works. You get it in your head real fast. But work on not just singing them, but saying them without the music, so you can say 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Good job. All right? Because when you can say them, it puts them in a different part of your brain and helps you better with multiplication later. So that's skip counting by 2s. Have you ever heard the word carrying?
Yes.
How about borrowing?
Yes.
They're lousy words because even though they're used a lot, they don't carry a very good mathematical connotation. So shouldn't probably say lousy, but there's more accurate words. And the more accurate word is called regrouping. And you can use it for both. But if somebody asks you if you can carry, you can tell them, yes, I do know how to regroup. All right? So regroup or rename. So here we have some numbers. What number is this first one up here? How many 10s?
34.
Okay, because every time we build, we try to write simultaneously. And then?
28.
Okay, because the reason that we use the blocks, let's review this, is so that we understand the concepts behind what we're going to do, understand the rules differently, but that when we see 34, you should be thinking, hey, that's 3 10s and 4 units. 2 T8, 2 10s, 8 units, right? You should be thinking those things in your mind. Now, somebody asked me one time, they said, Steve, aren't you becoming dependent on the blocks? And of course, I said, yeah, when I go to the bank, I says, give me 3 red ones, 2 blue ones. And then he laughed. That's what you're supposed to do, right? Okay. Because if I use the blocks all by themselves, yes, I would have to use the blocks all the time. But you know what? You have to use the blocks and the numbers, and you have to say it. So let's say these two numbers. 34 plus 28. Okay. Now, first we're going to add the units to units, because that's what we've been practicing. So the units plus the units, 8 plus 4, is the same as 10 plus 2, right? Okay. Now I can regroup. That's what I just did. I regrouped because I can't have 12 units, can I? So I have to regroup and make that a 10 plus something, because then the 10 is going to leave us in shortly, as you'll see. Now, is every value in the right place? Are the units in the right place?
No.
But what's this guy doing? Does he live there?
No.
No, because the 10s live where?
In the big blue house.
They live over here in the big blue house. And so, what are we going to do? Pretend that they're having a picnic, okay? And the units are having a picnic, and they invited this 10 guy over here, and he had a hamburger and all the rest, and then he got sleepy. And say, like, you guys could be the units, and I'll be the 10, all right? And I fell asleep at your picnic. What are you going to do when it gets dark and it's time for bed?
Wake you up.
Don't wake me up. Carry me home, and pick me up, and take me home, okay? Now, I don't know if that's going to fit in the screen there. Why did I take him all the way over here? Because this is where he lives, right? He lives in the units house. No, the 10's house. Okay, now let's write down what we've got here. Now we only have 2 in the units house, but we have one more 10 in the 10's house, right? Now can we add them all up? 2 plus 3 10s plus 1 10 is 6 10s. Does that make sense? Okay. This is called regrouping. Now, let's do the same problem, and we're going to use place value notation. See how this works. We have 30 plus 4 plus 20 plus 8. Now, do you see how this is the same as this? 2 10s, 8 units, 28, 3 10s, 4 units, 34, right? Okay. So we added 8 plus 4, and that became what? 12. So we put a 2 here, and we took the 10 over here. And then 10 plus 30 plus 20 is 62. And is that the same as we have here?
Yep.
Okay, let's do one more example. If you want to build this with me, 46 plus 35.
46 plus 30. 30 plus 5. 26 plus 35.
Yes, 46 plus 35. So we get 40.
I'm done. I need to make some 10s though.
Okay, 46 plus 35. Okay, I've got 4 10s, 6 units, 3 10s, 5 units. Okay, we're in good shape. In fact, let's go ahead and squeeze these over here, and we'll even put in our place value notation at the same time. 40 plus 6, 30 plus 5. Okay, what's the first step? We add the 10s or the units? Units. Start with the small guys. What's 5 plus 6 the same as?
11.
We're going to regroup and make that a 10 plus a 1, because we can only have 9 in the units place. Okay? Mr. 10 doesn't live here, so we're going to pick him up and we're going to move him. What are you going to do? Put him in like the wheelbarrow and just move him? Okay. Carry him home. Okay, so now we have 1 unit here and the 10 over here. We have 1 unit here and 1 more 10 over here, because this 1 really represents 10, doesn't it? Okay? And now we have 3 10s plus 4 10s plus 1 10 is 8 10s. 80. Very good. Okay, you're whizzes. Practice this some more. What do you think we're going to learn here? Skip counting by tens. Very good. And you recognize this is where we're going to write our skip counting facts in, our multiples of 10. And skip counting, this is even faster. You want to try me on this one? You have to count all the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. No, because I would win very quickly, wouldn't I? Okay.
You have to only count to 9.
So here we go. Instead of counting 1 through 9, we're going to skip those and say 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And you know what? That's the same as this big guy, isn't it? because there are 10 tens in 100, just like there are 10 units in 110. Okay, now what do we put down here? What if you saw this, if I gave you your sheets and I said, here, what do you put here? Got to fill in the numbers. I would look at these right away and say, look, they look like tens, but I have to find out how much in between each one and how much between those two. 10. Let's all do it together.
10, 20, 30, 40, 50, 60, 70, 80, 90, 100.
Okay, when do we ever count by tens in real life?
When you're in a race.
You're in a race?
Yeah, race by counting my tens.
Oh, okay, when you race me counting, all right. Where else?
In your school book.
Okay, but let's get out of our math books and just say, when do we use counting by tens? When do we use counting by tens?
When you have a lot of things in
How about if we count fingers? How many fingers?
10.
10, 20, 30, 40, 50, or count toes, because we have 10 of each of these, hopefully, right? All right. We count by tens. When else do you count by 10? Oh, what's this?
A dime.
A dime. How many pennies is a dime?
10.
10. So how many pennies in, I have 4 dimes here. How many pennies in these 4? 10, 20, 30, 40. Now, here's some tips. I've got a little special needs guy I've been working with, and when I teach him money, what I do is I put the 10 cent right on top of the 10 bar, so that helps me to know that this is the same as this, right? And then when I teach pennies, because you really have to teach pennies before you teach dimes, right? So what I do is I take all the little green pieces and I put a penny on each one. See that? And then I show them that 10 pennies is the same as 1 dime. So that might be a tip for you. What is the symbol for cents? If you want to say 10 cents.
C with a line through it.
A C that has been speared. Oh, no, C with the line. Okay, so we have 10 cents. How about 3 cents? What would I do?
3.
3,
C with a line through
3 cents, okay? And that makes sense. That's right, keep laughing. Okay, so 3 cents. That would be 3 pennies, right? And this would be 10 pennies or 1 dime. Very good, okay? What do you think we're going to learn in this lesson?
Count by fives.
Count by fives. Now, sometimes you don't have enough fives in your kit, so what you might want to do is take some 10 bars and turn them sideways, and they could be used, right? So I got a couple fives up here. Let's skip count by fives.
5, 10, 15,
20, 25, 30,
35, 40, 45, 50, 55, 60.
Okay. Now, what do the fives always end in? They either end in a 5 or a 0. A 5 or a 0. Notice how they always end in 5s or 0s. And this will help us when we get to multiplication. Okay? Which ones end in the 5s? If you only have 1 5, right? Or if you have 3 5s, so it turns out that if you have an odd number of 5s, it ends in a 5. See, 1, 3, 5, 7, 9, you know, odd numbers. And if it's an even number like 2, 4, 6, 8, or 10, they end in 0. That's a neat pattern. Where do we use 5s?
Counting money.
Counting money. Which part of money?
Nickels.
Nickels. And so here we have a nickel, right? So I would take my 5 bar, which is 5 cents, and I would put my nickel on top to remind me that that's the same as either 5 pennies or 1 nickel. Where else? Does that make sense too? That's very good. Where'd you hear that joke? Okay, now, have you ever seen a shape that has 5 sides? If you want to draw this, You can draw a house, but instead of making the walls straight, make them just lean out just a little bit. And then you're going to make a roof on the house. Looks kind of like a chicken coop, doesn't it?
Pentagon.
And that's called a pentagon. Penta means 5 sides. And there's a famous pentagon in Washington, D.C. Now, you know what's something cool about this? And it had nothing to do with the subject, but I think you'll like it anyway. Watch this. If you connect all the points inside, see, if you're interested in geometry, this is called, each of these is called a vertex. And you connect lines to each vertex, and you make a star. Oh, where's the other one?
In the middle.
This looks like Superman's chest, doesn't it? And it must have a pentagon here. Okay. And then you could make another little star right in here. Okay, I'm not going to make stars all day. Okay, that's your job. Okay, so learn how to skip count by 5s, 5 pennies in the cent. And something else, though, we're going to use skip counting by 5s. You know what that is? Minutes between each hour. And that's why we're doing it right now. What does this look like? When you see hundreds, tens, and units up there, doesn't it remind you of place value? And it reminds you of the base 10 system. And it turns out that in the base 10 system, at least in America, the only thing that we have that fits the decimal system is money. How much are these little guys here?
1 cent.
They're 1 pennies, 1 cent. How about each of these? They're dimes. Now, if these are pennies, how many pennies are there in a dime? 10. And how many dimes are in a dollar?
10.
Because there'd be 100 pennies or there'd be 10 dimes, right? There'd be 10 dimes in a dollar or there'd be 100 cents. Now, so far we've been writing money as, this would be 4 cents, this would be 50 cents, right? And we use the cent sign. But when you use dollars, you could say 100 cents, or there's a new symbol. You can say it's an S with 1 or 2 lines going through it, and that means dollars, okay? How many dollars do we have here? 2. Also, what you do is you use something called a decimal point, and that goes right there, okay? So when you see the decimal point, and this is 2 and not 200. If this was 200, you'd still use the cents. But if it's 2, then you know it's $2. And what do you do when you see that? You read and. Now you're allowed, because you only say and when you see the decimal point. So we have, very good, $2 with the symbol and 54 cents. Okay? So it turns out that the decimal system works beautifully with money. And money is a good way to illustrate problems in the decimal system. Okay, let's do one more here. You tell me how much this is. You write down the answer on your paper, okay? Okay, write down how much money I have up there. How much money do I have up there right now? In terms of dollars. Okay, it's $1. How many dimes?
None.
No dimes. How many pennies?
8.
8. And if we put the decimal system, decimal point, we have $1.08. And that is the same as 108 cents. Okay? But when you use the decimal point and you have the dollars as units, then that becomes the dollar sign. I want to round that number up. Now, can you round that number?
Yes.
Well, the first thing you should say to me, Mr. Demi, we're going to round it up to the tens place or the hundreds place, because it makes a difference, okay? If I say we're going to round to the tens place, you can just forget about this 3, because all I'm looking at is this and making that a 0. But at this time, I'm going to say, can we round this number to the hundreds? As soon as I say hundreds, you're looking right there to hundreds, right? Now, what two hundreds are close to this one? If I cover this up, how much is that? 300. And what's 100 more than 300? 400. Now, the key is, we don't want to look at the 3. Doesn't make any difference. If I say round to the hundreds, you only look over one place and to see what this is going to do to the number. Because when I round it, when I'm all done, these are both going to be zeros, right? Now, is this 8 going to make it go up or make it a 0? Up, right? So this is going to be rounded to 400. Let's try another one. 547, rounded to the nearest hundred. Okay, so what's the closest hundred here? 500. What's one more? Very good, 600. Now, am I going to look at the 7?
No.
So don't even worry about that. What you're going to look at is the one immediately to the right, the next place value that's smaller than the hundreds, tens. Is that 4 going to make it go up by 1? Down. Okay? So this one is 500. You get that? Okay, and why are we going to round stuff? So that we can estimate. And we're going to do that right now. Now, if you want to get your blocks, we're going to do a big problem now. We're going to do some hundreds. We're going to say 168 plus 235. Okay? So I'm going to build this one. 160 8, and here I'm going to have 200. I think I'm going to lower these a little bit. 235. Okay. Now where do we start when we add? Do we start with the big boys or the little boys? The little guys, because in case we have to regroup the little ones and make a bigger one. That's the way the decimal system operates. So what's 5 plus 8?
13.
Okay, that would be 10 plus 3. And now I can regroup that. Okay? Now, is the 10 in the proper place? Where does he go?
With the 10. The big blue house.
So I'm going to carry him next door, put him with the blue 10s. All right? And if I want to, right away, I can put a 3 over here where we're recording this. Okay, now, how many 10s do we have? We've got 6 here, plus 1 is 7, plus 3 is
10.
What's 10 10s make?
100.
Another 100. Boy, I've got to go to my box over here. Get another red one. Because these 10s, 10 10s is the same as 100. And I'm going to put him up here. Where are we going to put him? Got to make some space for him. Okay, now how many hundreds do we have? 4 hundreds. So let's write our answer down. We have 3 units. How many 10s do we have? None, because when we took the 3, we carried 1 10 up here, right? 1 10 plus 6 10s is 7 10s, plus 3 10s was 10 10s, which is now 100, right? And what's 2 plus 1 plus 1?
400.
403. Whew. What do you think? Did that okay?
I think that 2 plus 1 plus 1 is going to help.
2 plus 1 plus 1? Okay, here's what you're going to do, though. Just take 2 of them together. What's 1 plus 1?
2.
Okay, now think of that 2 plus 2, 4. We're going to come to that later, column addition. But what you do is you just group 2 of them and then group those 2. Just group them in 2 at a time. It's hard for anybody to add 3 things at the same time. So you do 2, and then make it 2. Okay? That was a good question. Okay, now I'm going to do this same problem with place value notation. Remember place value notation? Okay, how would I write 168 with place value notation? 100 plus 60 plus, good. How would I write this one? 200 30 plus 5. See, we're just breaking them up into place values. Okay, now, let's go ahead and add. What's 5 plus 8? Good, 13. Put a 3 here and a 10 here. What's 10 plus 6 tens plus 3 tens? 10 tens, or 100. And the hundreds are over here, so we don't have any tens, but we have another 100. What's 100 plus 100?
200.
200 plus 200?
400.
Good. So the answer is 403. That make sense? Now I'm giving you a whole bunch of ways to do this stuff. Some people might be fine with this. Some might want to use the blocks more. Some might want to use place value notation. I'm giving you a smorgasbord because people have different learning styles and techniques, okay? So I'm giving the teacher a lot of different ideas, and you find out which one works for your son or daughter. But the main thing is, I want them to understand it. When they see this 1 up here, they should be thinking that's 110. When they see the 1 there, that's 100. And if this helps them to do that, fine. If the blocks help them, use that. What do you think we're going to add in this problem? What do these things stand for? Dollar signs. If we have the decimal point, we're going to have the dollar sign, right? So what dollars are represented by this up here? How many dollars? $1. How many dimes?
4.
How many pennies?
2.
Okay, so that's $1 and 42 cents. Good. How about this one? How many dollars? 0. How many dimes? 1, 2, 3, 4, 5, 6, 7, 8. How many pennies? 7 cents. Okay, now we're going to add these this time. That's what this adding sign means. So what's 7 cents plus 2 cents?
9 cents.
9 cents. And that makes sense. Okay, and what's 4 tens plus 8 tens? 12 tens. I can't have 12. I'm only allowed to have 9. What do I have to do?
Oh, move on.
And think about this if this was money. If you had 10 dimes, couldn't you swap that for $1? So let's take, there's 8 here. We'll take these out. And if you want to, you can even see how, see 4 and 4 and 2 more. And see, that makes $1, right? So we can swap all those dimes for $1. Okay, where do the dollars go? Over here. Now, it's supposed to go up here, but I don't have room. So can I put it here? Okay, thank you. Okay, so what we have now is we have 9 cents. We only have 2 dimes because we carried 1 more up here, but we really put it down here, right? As long as we put it in the right place, it really doesn't matter too much. As long as you know that now we have $2 and 29 cents. Does that help you okay? Okay, you want to do another one, or is that piece of cake?
Do another one.
You want to do another one? Okay. See if you can build this one with me. I'm going to build $1.65. $1.65. And we're going to add that to $1.75. And what are 5 cents represented by? Nickels. Don't forget, these are nickels. Okay, so let's pull all these out here. 1, 2, 3, 4, 5, 6. Now I need another nickel down here. And I need 70 cents. 1, 2, 3, 4, 5. Six, 7. Okay, so what are we going to do first? Is that thing attacking me? Okay, what's 5 cents plus 5 cents?
10 cents.
10 cents. I can replace that and regroup. Where does the 10 cents belong? Belongs over here, right, with the tens. So now we have no more pennies, no more nickels, no more cents. Now, 1, 2, 3, 4, 5, 6, 7. 7 and 7 is how many?
14.
14. How many of those make $1? 10. So we're going to take out 10 more. Got 3. We've got 4, 5, 6, 7, 8, 9, 10 of them. And where does this go? Over here. And I'm just going to have to hold that and hope it doesn't fall. So what do we have now? We have 4 dimes left, but we took another dollar over here. Now we have $3 left. Let's $3.40. Did you all get that? Very good. Nice job. What do you call this? A lot of adding, isn't it?
Yeah.
And what do you call a bunch of numbers stacked like that? They are all stacked into a column. This is called column addition. And so what we're going to do is we're going to add these all up. Now that looks like a lot of work. In fact, do you like to add more than 2 numbers at a time?
I do.
And you know, sometimes, I'm going to give you a couple ways to do this. Sometimes what people do is they add like this. They say 4 plus 7 is 11, and they write it over here. 2 plus 8 is 10, write it over here. 3 plus 5 is 8, write it over here. Then they add 2 of those, and they just keep adding until they make them smaller. But you know another way to do it? If you know how to make 10, that's the key, because tens are what we regroup to make next door, right? Now, do you see any numbers there that add up to 10? Now, I want you to look at it for a minute. Now, 5, there's no other 5s. That doesn't work. How about 3s? 3 plus what makes 10?
7.
7. Now, you have to know how to make 10 real well by this point. Okay, so let's take this 7 and the 3 and say, that's a 10.
8 and 2.
8 and 2. Okay, so that makes another 10. Okay, and what's 5 and 4?
9.
So let's just put 9 in the units, and there's how many tens?
2.
2 tens that we regroup over here, right? And you can put just 2 marks, so you can put a 2. 29. Does that make sense? So the key to math often is not being able to do lots of stuff in your brain. It's being able to make lots of stuff into smaller little bite-sized chunks. And that's what mathematicians do. They know how to make problems easy. Nobody likes to add numbers like this in their head. But everybody likes to, oh, there's 10, there's 10, there's 20. 4 plus 5, 9, 29. Okay? So look for tens. All right? Now, let's try a little bigger one. And if I had a real big board and lots of blocks, I could do this with blocks, couldn't I? And if you have your living room, go ahead. You can put them all over the place. But let's see if we can find. First, we'll do the units. Any tens in the units place? You see any groups of 10?
Yes.
What do you see?
The 4, the 1, and the 5.
Okay, you said the 4 and the 1 is 5, plus the 5. Okay, that makes a 10. I'm going to do this 2 different ways.
5.
So there's 5 and 5, and that's 110, right? Put it up there.
2, 5. Here's 2, 5.
How about in here? We're still working in the unit. Forget this. We're working in the units place.
7 and 3.
7 and a 3, and that makes another 10, right? We'll put that up there. What do we have left?
6.
Just the 6. Now, is there another way we could have done that? How could we have done that a different way?
You do the 4 plus the 6.
You could have done the 4 and the 6 and the 7 and the 3, and you'd be left with 5 plus 1. You get 6. But either way, you've got 26. Good. Now we're in the tens place. Let's work in the tens place. You see any groups of 10 over here?
Yes.
What do you see?
The 4, the 5, and the 1.
Another 4, 5, and 1? Because we know that 4 and 1 makes 5, and 5 and 5 makes 10. So we'll just kind of circle these to show that they're done. And that's 100, isn't it? Because 10 tens makes 100. You see any more 10s over here? Well, let's start adding then. What's 2 plus 3?
5.
What's 5 plus 2?
7.
Plus 1?
8.
Plus another one?
9.
Let's do that again. I want you guys here to get this. Ready? What's 2 plus 3?
5.
5 now plus 2
7.
plus 1
8.
plus 1.
9.
Okay, so that would be 9 tens, and we have 196. Okay? So don't get discouraged when you see lots of numbers. Now, do you ever do columns of numbers like that? Sometimes when you're trying to balance your checkbook, or you're looking at budgeting, or how much money you've spent for the month, or mileage, this is the kind of stuff that adults do all the time. You have to learn to add columns of numbers, but make them easier problems. Now we're going to do some measurement, because one of the main ways that you, not main ways, but one that you use most frequently in real life is you measure stuff. And in America, what we measure is with inches. How big is an inch? Well, when I was a kid, it used to be my forefinger between my first 2 knuckles was real close to an inch. Now, if I wanted to know how long something was, I might take my little knuckle out. It was like my little portable ruler. I would measure things. Then, now what I've done is, I've measured how long my span is. I know how far from here to here. It's about 9 inches. And so when I have to measure something that's bigger, I'll say 9, 18, 27, 36. That's 3 feet, see, 36. So the main one is an inch though, and if you'll take your blocks, your orange block is real close to an inch long. Because remember, your little green blocks are half an inch. Okay, so these orange blocks are about an inch. Now the blocks that I'm using up here are real close to an inch. See that? Mine are 1 inch by 1 inch. Okay, how do you write an inch? If I said something is 6 inches long, how would I record that?
6 IN.
I put a 6, and I could put an IN, which is like an abbreviation for inch, or I could do this. 2 little slashes coming down means inches. Got that?
1 means a foot.
Okay. What's a foot? You think 1 slash is a foot? So like 1 foot? You're right. So if it's 1 slash, it's a foot. But what is a foot? You're standing on them, I know, and I'm standing on mine. But a foot
12 inches.
is 12 inches. 12 inches. And if you want to see one, how many inches would that be if this is 1? That's 10 inches, and this would be 12 inches, and this is a foot. Remember I told you my span was about 9 inches? See? Okay. So this is 12 inches, which is the same as 1 foot. Okay? Now, when would you measure something? Well, you can measure anything. You could measure your paper, you can measure note cards, you could measure lots of different things, but you can measure your nose. Okay, here, measure my nose. How long is my nose? Is it 2 inches?
Yeah. A little longer, 2 inches.
Little longer. Okay, let's not talk about it anymore. Okay. Now, how many inches would there be in 2 feet?
24.
Well, let's write it down. 2 feet would be 12 inches plus 12 inches. We add it up, and we get 2 plus 2 is 4. 10 plus 10 is 24 inches in 2 feet. How many inches in 5 feet?
60.
Let's try it. 12, 12, 12, 12, 12, because that's 1, 2, 3, 4, 5 feet, right? Now let's add it up. What's 2 plus 2?
4.
Goodness, why are we adding? We could be skip counting, couldn't we? 2, 4, 6, 8, 10. So we put a 0 here, put a 1 up here. 1, 2, 3, 4, 5, 6, 60 inches. Got it? Okay, now on your paper, what we've done is in your student sheets, we have lines that look like this. And that shows that it's 1 inch between here and here, and 1 inch between here and here, and 1 inch between here and here. So how long would this be?
3 inches.
3 inches. Okay, but that looks a little bit long. That's because I'm exaggerating. But in your student sheets, that really is real close to 1 inch. And we're going to ask you how long things are. Okay. When you measure the distance around, like my board, or the distance around a rectangle, we use a word that means, guess what? Distance around. And the word for distance is meter or measure. And the word for around is peri. And you put it together, you don't say perimeter, you say perimeter, which helps when you think about what this is, because here's how I like to write the word. Okay? What do you notice in there?
Rim.
Rim, because the rim is the outside edge. It's the distance around. So if you have a perimeter, let's say that I want to find the perimeter of this rectangle right here. Okay? Now pretend you're a little ant, and you're going to walk all the way around the rim. You're not going to walk on these flat parts. You're going to walk around the edges. How far, if you started right up here at this corner, how far over to this corner?
3 inches.
3 inches. How far if you slid down this side?
2.
2 inches. You hand over hand across this. 3 more inches. You climbed up this side. 2 more inches. And so the perimeter would be adding all of these up. What's 3 plus 2?
5.
What's 3 plus 2?
5.
What's 5 and 5?
10.
10 inches is the perimeter. And make sure you put the inches so it's not 10 feet or 10 units. Okay? The way we write this in the book, though, since we don't have pictures of the blocks, we have a rectangle shown like this, and we have little lines going out to show that this is where the little marks are. See? So this would be the same problem. How far from here to here?
3.
2.
2.
Don't forget, the perimeter is the outside rim around the problem. Okay? And we don't always have to have rectangles. We could even have a triangle. And we'll put the little divots or whatever here. Okay, each of these is 1 inch. How far from here to here?
2.
2 inches. How far across here? 2 inches. How far up?
2.
So the perimeter is 2 plus 2 plus 2, 6 inches. Got that? Okay, that's perimeter. For some of you, this will be the first time, the unveiling of different color blocks. But let's think about it a little bit. What is this little green guy called over here? Unit. Who's next? The 10. Who's next? 100. Now this down here is nothing significant. That's just my little block holder. All right? And it's not a 10 anymore. That's my block holder. So we have units, tens, and hundreds. And the units, 1 unit is green. And then the tens, 10 units is blue, and 100 units is red. So we kept to the same color scheme, and what we did was we produced some green hundreds, because when you put these all together, if you have units, tens, hundreds, and look, there's 10 of these in this, right? And there's 10 of these in this, so the next place value should have what? 10 of these in this. And so let's count them. 1, 2, 3, 4, 5, 6, 7. We ran out of space because there should be 8, 9, 10 all the way to the ceiling. And that's called the thousands place. That's 1,000. So 10 units makes a 10. And 10 tens makes 100. And 10 of the hundreds makes 1,000. And you start over again. 1,000. Now, How many of these should be in this place value?
10.
10. Remember, 10 units and 10, 10 tens and 100, 10 hundreds and 1,000 or 1,000. So we should have 10 1,000. So can you picture a whole line of 10 of these, and there should be now 10 lines. And we have 1, 2, 3, 4, 5 lines. This is only a half, 7. It should go 3 more and 5 more. It would be huge, right? And that's called 10,000. But because the 10,000 and the 10 units are both blue, we made these blue. What would the next one be? It would be 10 of these, honk, 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 all the way up to the sky. What color would it be?
Red.
Because it would be 100,000, 100,000. Because we got 1, 10, 100, 1,000, 10,000, 100,000. Okay, we've taken down all the blocks, we've cleaned up the board, and now we're going to write what we had built. Remember the little green unit? The blue 10, the red 100 square, and then we had the long line of hundreds that made 1,000. Then we had the big chunk of the blue hundreds that made 10,000, right? You only saw 3,500, by the way, which was close to 10,000. And then the 100,000 we couldn't even make because it was so huge. Okay? Now, let's put a number using all of these places. 456,789. Look at all those numbers. It's confusing. So what do? We put commas between these big chunks. And I like to think of the commas as having names. This guy's name is 1,000. Let's all say it. 1,000. So when you read the number, you never really have to read more than 100. Watch. 456,789. You try it. Ready? 456,789. Because all of these are the thousands, and the units, you don't have to say anything when you're all done. Now, how would we write this with place value notation? Watch. Here's 400,000 plus 50,000 plus 6,000 plus 700 plus 80 plus 9. And that's one thing that's nice about this. You don't have to put all these zeros in, right? But if you took the zeros out, you'd have the exact same number as this. Now, this place value notation, teachers, can be a real asset to some kids. It can be a little confusing to other kids. You make the determination of how much you want to use it or not use it. Now that we've had thousands, we're going to just practice rounding to thousands so we can estimate when we're adding with thousands. Okay, here we go. We're going to round some more. Which is that closest to if I say round to the thousands? As soon as I say thousands, if I was you, I just cover those up. So what's that? 4,000. And what's 1,000 more than 4,000? 5,000. Now, which numbers do we look at? Do we look at these nines, these huge nines that make things go up? No, because when we're talking about thousands, we only look to the one beside the thousands, the hundreds place. So these are not important. Now, is this 2 going to make this round up to 5,000 or down to 4,000?
Down to 4,000.
Down to 4,000. Very good. You know how to do this, right? You only look to the one to the right. So now let's use it in a real problem. Okay, we're going to add 4,299 plus 6,502. Okay, first thing we're going to have to do is estimate. See, even people that use, what's this? Calculators. They have to estimate because they have to know if the answer is close to what it should be, because sometimes calculators, the batteries get low, sometimes little finger goes and you hit an extra number. Sometimes the decimal point's in the wrong place. So you have to be able to estimate even if you don't want to do the adding. All right? So let's round this. We already did this. That's 4,000. Okay. I put it in parentheses just to show that that's an approximation. What's this round up to?
7,000.
Well, what's it closer to? Is it closer to 6,000 or 7,000?
7,000.
We look at the next number. 5 makes it go up, so that's 7,000. Okay, now let's add it. What's 7 plus 4? 11,000. That's what we think the answer should be real close to. Now let's go back and add. 2 plus 9 is?
11.
9 plus 1 is? 5 plus 2
7.
plus 1?
8.
8. 6 plus 4?
10.
So is 10,801 close to 11,000?
Yes. Yeah.
Yes. So that's good. Doesn't mean it's exactly right, but it means it's close. Okay? So this is a little bit of a check. All right. You got that one pretty well. Let me see if I can give you a tough one now. First, let's say it. Who can say this number? Right here. Can you say this number?
27.
And what's the name of this? 1,000. The little comma's name 1,000. 27,601.
601.
Very good. You didn't say 601. People like to do that and it's not right. It's 27,601. Can we round that to the nearest 10,000? Where's the 10,000 place? You tell me when to stop.
Stop.
See, that's the 1,000 place, and this is the 10,000 place. Okay, so we look here and we look to the right. Is this going to make this 2 go up to 3 or stay the same?
Up.
Up. So this is going to be around 30,000. Good. Good job. The key is what I tell you. Just while we got this one, let me give you a tricky one. Like tricky ones? Round that number to the nearest 1,000.
30,000.
Which number are you looking at? If you're looking at the nearest 1,000. The 7. Now, what's to the right of the 7?
6.
Does that make it go up?
Yes. 800.
So it's going to go to an 8. So the answer is 28. And these are all rounded, right? They become zeros. Get that? So read the instructions carefully, what it asks you to round. Wow, look at the size of this problem. Now you know why they call them problems. Because this is a lot of work. Okay. But before we add this, what are we going to do first? We're going to estimate the answer. But before we estimate, we have to round each of them. And we're going to round them because they all have hundreds. We're going to round to the nearest hundreds. So let's round this one right here. There's the 7. We're looking at the 7. What's the 5 make it do? Up or down? Okay. So this is 800. How about the 3? What's the 4 make it do?
Go down.
Okay. Looking at the 1 and the 6. Up. So that'd be 200. 5 and the 3.
500.
That goes down 500.
Up.
Up. So what's 1 more than 900?
1,000.
1,000. Okay. So we're going to put these in parentheses because they're just our little helpers. Now let's add these up. There are no units and there's no tens because we rounded. And now let's add the hundreds. 5 plus 2 is,
7.
plus 3 is 10. So we're going to have to carry 1. And then we've got 8. So 800, 2,800. Okay? Now let's go ahead and add. You see any tens in this first? We're only going to do one column at a time. Any tens in here?
Yes.
Where do you see the 10?
8 is 8.
Now I have one friend, he does this. He scratches them out. It goes like that. Because it tells him that he's already dealt with those two, so he doesn't add them again. Now what's 7 plus 2?
9.
9 plus 6 is
15.
15. So we put the 5 here, carry another one. Okay, you see any tens in this column?
4 plus 6. 4 plus 6.
4 plus 6. Okay,
5
so we'll put that over there.
5 plus
Oh, a 5 and a 5, good. Put another one over there.
And 3.
So we have 3 plus 2 is 5. Okay, you see any 10s over this column?
7 and 3.
7 and 3.
9 and 1.
Wait, put the 1 over here. 9 and the 1. 5 and 2.
7.
And we put,
2.
okay, 2755, we'd say 2,755. That's real close to that. You did an excellent job. What if you'd have had this, though? What if you'd have had this number, and I say, round this one to the nearest 100?
Go up 100.
Well, there's no hundreds now, right? But the 6 would make it go up, so it would be 100, wouldn't it? But what if this was a 4? And I say round to the nearest 100. How many hundreds here?
9.
0. What's this make it? 0. So over here, you just put down nothing. 0. Okay? All right. Bigger numbers to add. And I have to tell you frankly that that's why they made calculators. But still, there might be a time when you have to know how to add these yourself, right? Like if the hurricane comes through and you don't have any power and your machines don't work, so you have to add these. I was in a restaurant one time at it was a fast food restaurant, and guess what happened? The power went out. You know what was sad to see? There was nobody in the restaurant that worked there that could make change. And finally, they found one person in the back that was peeling potatoes, and this little girl came up, and she was the only one that knew enough math to solve these problems. It was really sad because there was a lot of people that worked there, and nobody could even, if you gave them $5, they couldn't subtract to give you your money back. So this is important stuff that you need to learn. So the first thing we're going to do is estimate by rounding. So these will all be round zeros because we're going to round to thousands. So what's the closest 1,000 to 8,000? We look to the next number. Does the 5 make it a what? Up. So that would be 9,000. 2, look at the 7. That makes it go
3,000.
up again. 3,000. The 3, we look at the 6 and it up again. 4,000. Now let me give you a little tip here, because there's even little techniques when you estimate. If all 3 of these have been rounded up, then probably this is going to be a lot higher than our real answer, right? Because we added 300, 400, 300, 500, right? To keep bumping it up. It's usually better if in the problem some of them are down, some of them are up, and they kind of bounce each other up. Okay, now what's 9 plus 3? 12 plus 4. 16,000, okay? And I think this is going to be high. I think our answer over here would be lower. Now let's go ahead and add. Any 10s in this row here? This column. There's a 10. Okay, any 10s over here?
6, 3, and 1.
How did you know 6, 3, and 1? That's good though, because 6 and 3 is 9 plus 1. So this whole thing here is a 10. We're left with 5. Any 10s in this row?
2 and 8.
No, that's this row. We're going to look in this column here first, and there aren't any. This is the ones that are tough. You just have to know how to add. Okay, I like to pick the 2 big boys first. What's 6 and 7? 13 plus 5, 18 plus 1, 19. So pick the toughest ones and then work down. Do you see any 10s over here? Okay, 2 and 8, so we have to carry 1 over here. Regroup the thousands to make 10,000. 3 plus 1 is 4. Okay, so 14,954. And that's less than that, but I predicted that, right? Because if you're bumping all of them up, this is going to be a little bit high from the original answer. Okay? Do you remember this phrase that I've said a couple different times on different videos, but at least once in this video? To compare or combine, you must be the same kind. Now when I say compare, that means greater than or less than, right? But when I say combine, it means adding and subtracting. So in order to add or subtract, you must be the same kind. In other words, you don't take the 5 minus the 2, or the 9 minus the 4, and the 7 minus the 3, because you can only add and subtract units to units, tens to tens, hundreds to hundreds. Okay? All right, now, we're going to subtract this. So we're going to do the units first. What's 7 minus 2?
5.
5. Or, what plus 2 makes 7? 5. What plus 4 makes 5?
1.
1. Or 5 minus 4. And what place is that? These are the tens, right? That's really 5 tens minus 4 tens is 1 10. And now we're in the hundreds. 900 minus 300 is 600. Very good. Now I'm going to try this one. And as I said before, this is optional. And even though you have these little pluses in here, that just is the number itself. Okay, now we're going to subtract. What's 7 minus 2?
5.
5. What's 50 minus 40?
10.
And 900 minus 300?
600.
600. 10 and 5, which is 600. 10 and 5, 615. That make sense? Okay. How do you check a subtraction problem? Add it back up. And sometimes I put little curvy lines here to remind me that now I've got these two things. I'm going to add this. What's 5 plus 2?
7.
What's 1 plus 4?
5.
6 plus 3.
9.
And these should be the same, shouldn't they? Because subtraction and adding are opposites or inverses. Okay. Let's do one, though, with some zeros. Now, because it's important that you compare and combine to be the same kind, once again, turn your paper sideways. And when you do these problems, make sure that you have all the units in one place and all the tens in the next place, and then the hundreds. Okay, 8 minus 8,
0.
or what plus 8 makes 8? 0. 9 minus 0?
9.
9. 5 minus 2?
3.
3. And this is 390. That's it? 390. Good. All right. Want to check it? 8 plus 0.
8.
0 plus 9. 2 plus 3.
5.
Is that the same as that? Yes. Okay, you did it correctly. Now that you can skip count by tens, I want you to tell me how many blocks I have up here. There's 10, 20, 30, 40. Take a deep breath. 50, 60. Now, what do you know that has 60 in it? Well, it turns out that your watch clocks have 60 minutes. So we're going to work on telling time, but we're going to break it up and just do minutes in this segment, okay? Ready? Now let's make, that doesn't look like a clock to me. It looks like, what? Lines. Blue corn. Okay, so here's what we're going to do. Let's make a clock out of this 60 minutes here. Okay, how's that look for a clock? Yeah, it looks kind of weird to me too. Because you know what they really do? Instead of making it in 10 minutes chunks, what do they do in a clock? 5-minute chunks. And so they have 5 minutes and 5 minutes, and so you can replace each of the minutes with 5s, and if you run out of 5s, you can get like a 2 and a 3, right? And then we can start massaging this and make a clock. But you don't have blocks this big at home, do you? Although they'd be fun. You could put them on your refrigerator, huh? Okay. So what we're going to do is we're going to take something that's in your books. It's called a template. And it's got the blocks in there. And it's got places for the blocks. And there's 2 pages to the template. And so what you do is you take this, and you tape them together, and then you have a little clock template. Okay, now, so what I've done is I have got a bunch of magnetized pieces here. I need a beautiful assistant. Can you come up there and hand me those, please? Thank you. I mean a handsome assistant, excuse me. Okay, I need all of these pieces right here, these little colored pieces with magnets on. And how many minutes between the first two sections there? Look. 5. Now how many minutes are there? 10. Now how many minutes are there? 15. 20. 25. Now, what if I run out of 5s? What can I use instead of 5s? 2 and 3, or I can use 4 and 1. And so you can be creative because you can make a clock. We call this a block clock. A block clock. And you can use your blocks to make a clock. Now, how many minutes from here, which is the starting point, down to here? 5. How about from here to here? 10. Because you always start at the top, okay, which is where there's a 12. So you go 5, 10, 15, 5, 10, 15, 20. And what I decide to do is, I decide to make this the minute hand. And this tells us, because there's 60 minutes in an hour, whatever this is pointing to, that's 0, then what? 1, 2, 3, 4, 5. Now, even though we go in groups of 5, sometimes the minute hand stops on a number that's not at the end of a 5. Sometimes it stops right there. How many minutes would that be? Start up here. 5, 6, 7, 8. How many minutes would this be? Whoa, that's right. 5, 10. Okay, now let's go find this one. How many minutes is this? 5, 10, 15, 20, 25. Good. I'm going to move it one space.
30.
Nope, not 30.
26.
5, 10, 15, 20, 25, 26. So you can skip count to be the big chunks, and then make sure that you know that each of these little squares represents 1 minute. All right? Because a real clock, these would be round. Okay, who wants this next one? Okay, you all said me, so I'll try you in this one. Ready? Let's start the beginning. 5, 50,
20, 25, 30, 35.
35 goes right to there. Now what? We need to go by ones now. 36,
37, 38.
38. Very good. That's a tough one, right? Because you can go by the 5s, but when you get to the end of the 5s, you have to start going by just individual ones. Okay, let's see if I got enough up here to make the rest of my clock. How many minutes are there in a clock? All the way around. You remember that already? 60. Okay, so we have 45, 50, 55, and there's my last one, and there's 60 minutes. Oh, let's make room for Mr. 60 to get in there. There we go. Okay. Okay, going to give you one over here now. Ready? There you go, Professor. You want a tough one or an easy one? That mean tough or easy? Easy, okay. Okay, start the beginning.
5, 10, 15,
20.
25, 30, 35, 40, 45.
45. Bingo. Tough one?
Yes.
Okay.
5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55,
55. Now we get to stop and count.
56.
Yeah. Oh, I want this one right here. 56, 57, 58, 59. That's the highest you can go. Because when you get one more, you don't say 60. You know what you say?
1 hour.
O'clock. You say o'clock because that means it's right at the top. So we start at 0 and go all the way around 59, and then you start over again, and it's a double zero. All right? So that's practice counting minutes. Now we're going to subtract with regrouping, otherwise known as borrowing. So we'll use both words here, but we're really going to regroup tens for units. But when we subtract, we know that we take these and we put them upside down on top of these, right? Now, can you take 8 from 2? No. We're stuck, right? What are we going to do?
Borrow.
Well, see, when I grew up, I lived in an area that had lots of houses close to each other, kind of like a subdivision. And if we didn't have enough gasoline for the lawnmower, we went next door and borrowed some from our neighbor. Or if my mother was cooking and she didn't have enough flour, she would say, run next door and borrow some flour from Audrey, that was our neighbor. Or Dolores on the other side. And so I would run over there and we would borrow stuff, right? So who lives in the first house on the street? Units. Who lives next door? The tens. So if you don't have enough units up here, where are you going to go to borrow some? The tens. And so, see, Mr. 2 is in trouble because they're trying to take 8 from him. He doesn't have enough, so he goes, help, help. Right? He says, I need to borrow some. So who comes running over to help? 10. Mr. 10. He comes running over to help. Okay, now, before you do anything else, you have to write down what you did. Now we only have 3 tens here, but we have how much over here?
12.
10 plus 2 is 12. Okay, now, can we take 8 from 12?
Yes.
And how much do we have left? We have 4 left, right? So if we had 12 and we take away 8, we only have 4 left. So all of this can be replaced with this. Okay, now can we take the 10 upside down here?
Yep.
And how much does that make?
24.
This is 0, right? Have 10, oh 10. So what we have left is 2 tens and 4 units. Does that make sense? 12 minus 8 is 4, and 3 tens minus 1 10 is 2 tens. That work? Okay, let's try one more. 65 minus 27. 65 minus 27. Okay, there's my 27. Need 65. Okay, we have 65. We got to build it, and we're going to write it minus 27. Okay, can we take 7 from the 5? No. So Mr. 5 is going to say, help, help. Mr. 10 comes running over, and he's going to help them. Okay. So now can I take 7 from 15? But guess what? I went too fast. I got to write this down. Now I only have 5 tens here, and I have 15 here. Now I can subtract 15 minus 7 is what? 8, right? So I can replace that with that, and I have 8. And if I take 2 tens from the 5 tens, how much do I have left?
38.
3 tens, 8 units, 38. That make sense? Okay. Bingo. Okay, now you're experts at counting minutes, right? And notice that in the minutes here, I picked that all the nubs are showing. Notice that? And so the minute hand, all the nubs are showing. But guess what? We have something else beside minutes. We have hours. And how many hours are there in a day? 24. But what we do is we go from to 12 and then to 12 again. We do 12 twice, okay? Unless you're in the military, then they go all the way to 24. So in order to keep the minutes and the hours separated, what we're going to do is we're going to put these upside down so the hollow side is showing, and this would be 1 hour, and this would be 2 hours, and where's my little 3 hours? There's 3, And when you put the hours and the minutes together, then we're going to be all done. Okay, there's 4. And where's Mr. 5? Thank you. 5. And 6 is straight down. And we have 7, 8 o'clock, 9 o'clock, 10 o'clock. How do we do 11? Add 1 more. How are we going to do 12? Add 2 more. Okay. Now what are we going to do for an hour hand? Because the hours are all hollow side showing, we're going to make the hour hand hollow side showing. That make sense? So I'm going to forget about the minutes just for a second, and just for a minute. And then I'm going to come back. Now, what's hour is that? 1 o'clock. How about this one?
2 o'clock.
3 o'clock. 4. And that's, okay, that's easy, right? But the tricky part is, what if it's pointing between 2 numbers? That's the hard one. So we're going to point over here. Didn't you just have a birthday? Okay, how old are you now?
9.
But you used to be 8. Okay, so let's pretend that this was when you were 8. Okay? Do you like to have birthdays? Okay. See, when you get older, it's a little bit iffy. But when you're younger, we like to have birthdays. So this is 8th birthday. How old were you the next day after you turned 8? The next day after you had your 8th birthday party? Still 8. How old were you the next month? Still 8. How about the next month? Still 8. Do you remember how long it was between your 8th birthday and your 9th birthday? It seemed like it would never get there, right? So when you had your 8th birthday, the next morning it's 8, the next week it's 8, the next month it's 8, 8, 8, 8, 8, 8, 8. Do you remember the night before you had your 9th birthday? When you went to bed and you're thinking, tomorrow is my birthday? How old was she, everybody? 8. How about the minute before midnight? How old was she?
8.
She was still 8. Even though she was almost 9, she was 8. So everywhere between 8 and 9 is what? 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, 8. Hey, you had your 9th birthday. You are now 9. How old are you the next day? 9. Christmas that year. 9, 9, 9, 9, 9, 9, 9, 9, 9. And someday you're going to be 10.
Like me.
Okay. Everybody get this? Okay. So when it's between 2 numbers, it's always the smaller number. Even though it's almost 4, it's still 3. Okay, so tell me what number this is pointing to. 9. What number is this pointing to? Anybody? 6. How about this number right here? 4. How about this one right here?
5.
Still 4. How about this one?
5.
That's still 4. Okay? Now we're going to put it together with the minute hand. Okay? So the first thing you do is you find out what hour, and then you put it together and find out what minute. So let's look at this. What hour is that? 2. Okay. What minute is that? Let's go back and skip count. 5, 10, 15, 20, 25, 30, 35. So the time is 2 hours, 35 minutes, and you put 2 dots there, so it's 2:35. Okay, want to try another one? And you can practice these all the time. Okay, let's try this one. Okay, who wants this one? Okay, what hour is it? First thing you do is the hour. It's between this and this one, right? 10. Okay, put the 2 dots. How many minutes is that?
4.
No. The 4 is the hours. The minutes are these, right? So let's go. Start up here. 10. No. I'm sorry. 5, 10, 15, 20. So it's 10, 20, right? You want one? All right. Very good. Because when the minute hand is pointing straight up, remember I told you? That means that you have no minutes, but you say o'clock. And if the hour hand is pointing right up there, that's pointing at the 12. So that would be 12 o'clock. Whenever you see 00 straight up, it's what, everybody?
12
o'clock. Okay. Now we'll give you another one now. You did the hard one. Let's try. Okay, now we haven't had this one yet. This is between 12 and 1. Uh-oh. Because technically the 1 is smaller, isn't it? But it's still 12, 12, 12, 12, 12, 12, 12, 12 until it becomes 1. Then it's 1, 1, 1, 1, 1 before it becomes 2. Okay, so what time is this? What's the hour first?
6 5
Oh, wait, I was messed up. That's what I was trying to do. Sorry. My mistake. Okay, okay, that's 12. Okay, now what's the minutes? 5, 10, 15, 20, 25. Got to start counting singly now.
6 27 28
12:28. Very good. So you skip count as far as you can by 5s, and then you start counting them one by one, right? Okay. Now we're going to regroup with hundreds. So we have 245 minus 167. Now when we added, we started with the little guys and went to the big boys, right? We do the same thing when we subtract. We're always going to start with the little guys. Now can we take 7 from 5? No. What are we going to do? We're going to borrow one. We're going to take a 10 and bring it over here. And so now we have 15, but now we only have 3 here and 15 there, right? Still 45. Now, can I take 7 from this? And if I wanted to right now, I could subtract. But I'm going to go ahead and just get everything set up. Now, can I take 6 10s from 3 10s?
No.
What am I going to do? I got to borrow again. So I'm going to take one of these hundreds and bring it over here. Now, if I wanted to, I could take this and turn it into 10 10s and bring it over. But I think you know that this is the same thing, right? Because there's 10 10s, so now we have how many 10s here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 10s. So but we only have 1 in the hundreds place. Let's move it a little bit like that. Got 1 in the hundreds place. We've got 13 10s in the tens place, right? Okay, now we can subtract. So we take 7 from 15, and what do we get?
8.
8. That's the same as 8. Okay? We'll put an 8 here. Now we're going to take 6 10s, take it from 13 10s. How many are you going to have?
7.
7 10s. Because there's 1, 2, 3, 4, 5, 6. These would go, and these will go. And it's going to leave 7. Okay, so we'll put a 7 over here. If we take 100 from 100, what do we get?
0.
No hundreds. So those are all, whoop, saw the back. So the answer is 78. Let's check it just to see if that works. 167 plus 78. What's 8 plus 7? Carry the 1. 7 plus 6?
13.
Plus 1? Carry the 1. 245. 245. That's what we started with. Whew, what do you think? Do that okay? Okay, let's do now one without the blocks. 202 minus 78. Can I take 8 from 2?
No.
What am I going to do?
Borrow from the
Borrow from the 0. How can I borrow from a 0?
kid.
You can't.
Borrow from the 100.
Borrow from the 100. So let's take this 100 and make this 10 10s. Can we do that? Now can we borrow one from here to go over here?
Yes.
So this will become 9 10s, and then we have 12 units. Whew! That's tough, huh? But as long as all of these up here are bigger than all these down here, then we can subtract. So can we take 8 from 12?
Yes.
4. Can we take 7 from 9?
Yes.
2. And 1 minus 0 is 1. How's that? Okay? So don't let zeros get you unnerved. You can always keep going over here and get bigger ones, make them into smaller ones, take one of these and bring them over here. Numbers that tell order, or which order, like are you the firstborn, secondborn, right? And you're the secondborn, correct? I'm the firstborn, he's the fourthborn. So numbers that tell order are called ordinal numbers, ordinal numbers. And so like what's the first day of the week?
Sunday.
Sunday. What's the third day of the week? Tuesday. And so numbers like first, second, third, fourth, fifth, sixth, most of them end in what? Sixth, seventh, eighth, ninth, 10th, they end in TH, all right? Now, what about the first month? What would that be? January. Second month? February. This is a good time, if you don't know the days of the week and the months of the year, to go ahead and memorize them. Now, how many days do we have in each month? And month comes from month. So month tells you that it has to do with the moon, but the cycle of the moon is not quite a month. How many days in a month?
30 or 31.
30 or 31 or
28.
28. There's one month that has 28 or 29 every 4 years when they have leap year. So how do you tell though? If I said like how many days in April? Here's how my grandfather taught me. And there's ways you can do it. There's a poem. 30 days has September, April, June, and November. All the rest have 31, except for February, which doesn't have any. No, it has 28. Okay, so here's how I learned it with my knuckles. And you have pictures of this in the teacher's manual. And the knuckles, if they're atop of the mountain, they're 31. If they're little hollow things, they are 30 or 28. Okay, so let's start with January. January has how many days? 31. February, March has 31. April, May has 31. June, July has 31. And July and August are side by side. They both have 31. September, October has 31. November, December has 31, right? So the ones that have 30 are April, June, September, November. And the one right here that we don't know, because it depends whether it's a leap year, has 28. That's the way you can tell days and months. All right? So what is the 10th month? Well, January, February, March, April, May, June, July, August, September, October, 10th month, October. All right, so that'll help you. Now, if you are also, you could use the commandments. You know what the commandments are? Okay, so you could take like the 5th commandment, which is one of the parents' favorite verses, because it says, honor your father and your mother, see? So that's the 5th commandment. There are 10 commandments there. And if you were counting things, let's say that you were standing at the door today, and every time somebody came in, you wanted to tell how many people were in the room. So what would you do? You could count, but you know what you could do? You could just go like this. 1, 2, 3, 4. What do you do for 5? You put a slash across. This is called keeping a tally. And I think that's what they used to use in the old days when they had all the cattle coming through the chutes. They would sit there, the guy up there sitting on top of the fence, tung, 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 tung. So every time you come to 5, you put a line through it. So then you keep going. 6, 7, 8, 9, 10. Does it make any difference which way I go? As long as you know that you take 4 and you put a line through it, that makes 10. So show me 3 with your tally marks. 1, 2, 3. Okay, show me 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, right? Okay. And if you use that when you're riding a horse, what do you say? Tally ho. Bad joke, just made it up. Okay, who wants to subtract this big guy? All right, first we're going to see whether we can, right? Can we take 7 from 1?
No.
So what are we going to do?
5.
So we're going to make this a 7 and bring 1 over. And now the units are all set. And if I wanted to, I could go ahead and put a 4 down there because that's cared for, right? Or I could wait. Now, can I take 9 from 7?
No.
So I have to go over here and right? And every time I take 100, that's why it makes 10 tens, which is why I put a line there. Okay, so what's 9 from 17?
8.
8. And what's 3 from 4? 1. I can do that one okay. And
3.
so we're all set, right? Okay. You want to do another one? Try this one on your paper. 3,062. 3,062 minus 1,549. So 3,062 minus 1,549. Okay, just looking at this real quickly, which ones are going to give us trouble? I think this one's going to give us trouble. This one looks good. This will give us trouble, and this one looks good. So let's go slowly here first. Can I take 9 from 2?
No.
No, so I'm going to have to borrow 1 here. Now I only have 5 tens, but I have the other 10 makes 10 units, so I have 12. And 12 minus 9 is 3. Can I take 4 from 5?
Yes.
Okay. Now can I take 5 from the 0?
No.
No. So I have to go over here, borrow. 10 minus 5 is 5, and 2 minus 1 is 1. Because we borrowed 1, right? Did you get that? 1,513. Very good. What does this look like to you up here? If you have these dots, that's a little indicator that those are decimal points, right? So what do you think this is? It's money. But I forgot to put the dollar sign, right? Okay. Because when you see the decimal points, you're going to have the dollar sign. So how much money do we have here? $1. How many dimes? 5 dimes. So that's $1.50. What do we have over here? No dollars. 6 dimes, 9 cents. So we have 69 cents, and we're going to subtract. Okay. Now I know this is not a hard question, but can we subtract 9 from nothing? No. So what are we going to do? We're going to bring 1 over here, and now this dime becomes 10 pennies, right? So now we only have 4 dimes here, and we have 10 pennies over here. Now can we take 9 pennies from 10 pennies? Yep. What do we have left? 1 penny. Very good. Put the 1 here. Now, can we take 6 tens, 6 dimes from 4 dimes? What are we going to do? We're going to make this dollar come over, and he's going to help us out, and he's going to become no more a dollar, but now he's 10 dimes, okay? And can we take 6 dimes from 14 dimes? Okay, so if we put these 6 upside down on top of these, then 1, 2, 3, 4, 5, 6 would be gone, and they'd be left with 4 plus 4, or we'd have 8 left over. Okay? So 14 minus 6 is 8 dimes. So the answer is 81 cents. So subtracting money is exactly the same as subtracting in base 10, except instead of hundreds turning into tens, we have dollars turning into dimes, dimes into pennies. What do you think about this big subtraction problem? Taking a deep breath? Does it look large? It turns out that if you can subtract just one from another, pretty soon it's just the same principle over and over, right? So let's look at this one. Can we subtract 0 from 5? Yeah, and the answer is 5. Can we subtract 6 from 8? Yes, because 2 plus 6 makes 8. Very good. Good. Can we subtract 7 from 0? Now we need to regroup. So we'll take 1,000 and make it 10 hundreds. Now 7 from 10, or 3 plus 7 makes 10. How about 3 minus 9? Nope. So we're going to take a 10,000 and make that 10 1,000s. 9 from 13, or 4 plus 9 makes 13. 1 plus 1 makes 2. All set, right? Okay, let's check it. 5 plus 0, 2 plus 6 is 8, 3 plus 7 is 10, 10 plus 4 is 14, 1 plus 1 is 2, plus 1 is 3, 34,085, 34,085. So that works. This is called a gauge. Which kind of gauge do you think that is? What do you think the E and the F stand for? Well, because I have one of these in my car, and it's called empty and full. This is my gas gauge. And if it's 10 to here, how many gallons do you think there are totally in the tank? 20. So this would be 20 over here. This would be 0 over here. This is where it's empty, right? And if the gas gauge is pointing to here, how many gallons of gas do I have in my car? Well, this is kind of like the problems we had before, where we had 0, blank, 10, blank, 20. What numbers do you think go in between there? 5s, okay. So this would be 5, 10, 15. So if you want to write them in, you can. This is 5 gallons, 10, 15, 20. So how many gallons of gas in my car? 5. And so what we're looking for is a pattern, is how much between each space. Okay? Now I also have a coal stove in my basement. And the coal stove goes up to 600 degrees. So we're going to put in some lines here, 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 here. And I'm going to give you these. This is 0 degrees, 600 degrees. This is 400 degrees. This is 200 degrees. And I want to know what the temperature of my coal stove is right there. And these little zeros up here mean degrees. Okay? So the first thing you want to find out is how much between each space. What do you think? If it's 0, blank, 200, blank, 400, blank, 600, you think there's 100 degrees? So add 100, add 100, add 100, add 100. That's right, 100 degrees between each one. So what's the temperature of my coal stove? 300 degrees. And it does get that hot on the surface. So that's why they have protective stuff, right? Okay. So when you're reading gauges, the first thing you want to find out is how much between each spot, and then go back and read the gauge. Now, have you ever seen a thermometer on a chalkboard? Okay, you're about to. This will be a thermometer. And this is the mercury down here that rises in the thermometer. And it goes up to 16 degrees, must be a Celsius. And this is 0 degrees. And this is 14 degrees. And this is 10 degrees. And so what I want to know is, if it's shaded right up to here, how many degrees outside is it? Okay, first thing you want to find out is how many degrees between each line. What do you think? How many between this one and this one? 2. And if there's 2 more, this would be 12 degrees. What about here? 8, 6, 4, whoops, 2, 0 degrees. So how many degrees in my thermometer?
8.
It's 8 degrees. Is that cold? Okay. If it's Celsius, it's not too bad, but if it's Fahrenheit, it's cold. Okay, so 8 degrees. So find out how much each unit is first, and then go back and read the thermometer. Okay. What do you think these names are down here? J, J, E, I. Yes.
Justin, Joseph, Ethan, Isaac. Probably Johnny. Oh yeah, Johnny.
Oh, you could be in it if you want to be, but these are my 4 boys. John, Joseph, Ethan, Isaac, and this is taken a long time ago. This is not the present dates because they're older now. In fact, just about 10 years older, but this was 10 years ago we made this problem up. And what we have down here, we have their names going across here, and up the side here we have their ages. And this is called a bar graph because we have bars in there. So, you know, bar graphs, though, they give you without, if I had told you they're 5, 8, 11, 13, you have to think about that. But a bar graph, you look at that and you say, oh, the youngest one is 5, the oldest one's 13, right? They're all pretty much same progression. There's 2 years between these two, 3 years here, 3 years here. So a bar graph gives you a quick visual look. And you need to know how to read it, though. So if you look across here, what if, for example, okay, you all set on this bar graph here? Okay. What if I decided, though, to take and just put a little dot on the top of each of these and take away the bars? And so now we just have dots. And then I could connect the dots, right? And that would be a line graph. And you could look at that right away. And if I said, how old do you think Ethan is? Well, you go over to Ethan and you go up here, and you go across over to here, 11, right? How old do you think Joseph is?
8.
I should put a Joseph here, right? And a John here. So you go and you go over to here, 8. How about John?
5.
And you go up from John, he's 5. This is the ages. And then Isaac would be all the way up here, and he's right there, he's 13. Does that make sense? Okay, so a lot of things, though, that we can write with graphs. We can do rainfall, we can do how much snow you've had, how many hours of daylight, how much money you made each day. Maybe you made $5 one day, and then you made $4 the next day, and then if you're rich, right? And if you make $10 a day. But graphs are kind of a neat way to look at it, and you can see progressions.